We're going to be continuing in the blood chapter, starting at leukocytes. Who knows what page that's on, because I didn't put page numbers in this set of notes. This is after polycythemia and blood doping. So, what are leukocytes? If you break that word down, leuko is white, cytes is cells, so these are white cells or white blood cells. What's the overall function of these cells? Immunity. They're all coming at the problem from a slightly different direction. They are all phagocytes, but they can all also do some other things, generally speaking. And so again, all coming at immunity from slightly different angles, essentially. There are some special features that white blood cells have that none of the other formed elements of blood have. One of those is diapedesis. So when you get infections in your body, they better not start in your bloodstream. They start outside. Like if you step on a rusty nail, it's starting outside of the blood in your foot. And so the white blood cells need to be able to leave the blood and get to the area where the infection is. And diapedesis is the ability to do that. And so you can see in this picture down here, this is a white blood cell called a neutrophil. This is, of course, the blood vessel, and that neutrophil is no longer in that blood vessel. So it has undergone diapedesis and it has left the blood vessel. Here, sort of another image of the same thing. Here's your white blood cell, not in the blood vessel anymore. Once they've left the blood vessel, they are not just traveling by blood pressure. They actually move around on their own seeking out food. And the food that they are seeking out are cells that are not yours. So bacterial cells, hopefully not transplant cells, but they will seek that out because it's not yours. Generally speaking, we want them to find pathogens. So fungal cells, protist cells. Viruses aren't true cells, but we want them to find viruses and eat those too, bacterial cells, those sorts of things. The way that white blood cells move around is through a process that is called amoeboid motion, and it's called that because there's a specific organism called an amoeba. This is a cartoony GIF that shows you how an amoeba moves around, so that's why it's called amoeboid motion. I'm not as old as this movie is, I swear to you guys. I know it seems like I'm crazy old, but there's an old movie called The Blob. Think of white blood cells as the blob. They sort of ooze around looking for things to eat that are in you and are not supposed to be in you, essentially. It is important that you understand they are active hunters seeking things out to try to eat. Okay, so the amoeboid motion is how they move. The chemotaxis is how they know where to go. Essentially, they are following a chemical trail so that they can find what they're looking for. So here in this little GIF, those little bitty specks are some random coccus-shaped bacteria. It's a diplococcus, and this big old blob moving around by amoeboid motion. It's following the chemical trail left by the bacteria to find the bacteria so that it can eat it. So again, they're not moving randomly. They are hunters looking for food, and when they find the food, they are going to engulf the food and then eat it. Okay. If you have a real infection that is going on, your body can actually up its production of white blood cells to ensure that your army is big enough to actually defeat the pathogens that have entered your body. So leukocytosis sort of has two definitions going on. From a clinical standpoint, leukocytosis is defined as having an elevated white blood cell count. Different clinics, different hospitals, different books all have different definitions of what an elevated white blood cell count looks like. It can be over 10,000 cells per microliter. It can be over 12,000 cells per microliter. I want to say your book says 11,000 at this point, but honestly, they change it with every edition, so who knows what they're saying at this point. In this particular context, though, what we're talking about is the creation of more white blood cells. That happens as a result of a bunch of chemicals that get released that we'll talk about a little bit more when we get to the immune system. Those chemicals are going to help your bone marrow churn out white blood cells faster and help you make what's I'm going to keep calling a clone army when we get to the immune system, so you can just up your white blood cell count. Okay, compare and contrast the granulocytes with the agranulocytes is what you have going on next. Here, I gotta find the right pen. There's a stupid mnemonic to help you sort of remember the overall white blood cells and their approximate percentage. It is 60. I gotta be in the right place. Oh, and I have to turn the pin on too. Guess what? Things don't work if you don't turn the pin on. I had it on earlier, and then I turned it off. All right, so stupid memory trick is 60, 30, 8, 2, 0. Never let my engine blow. Sorry, I'm writing over a picture. Okay, so there are 5 distinct types of white blood cells that you can visualize on a blood smear. The N stands for neutrophil. I'm going to abbreviate that as neutro. The L stands for lymphocytes. The M is monocytes. The E is eosinophil or eosinophil. Don't care which way you say that. The B is for basophil. Okay. The numbers over here are the approximate percentage, usually somewhere in the middle percent that you're seeing off over here. So your most abundant white blood cell is a neutrophil. Your second most abundant in the bloodstream is the lymphocyte. Now, you actually have way more lymphocytes than that. It's just that they don't really hang out in the bloodstream. They're called lymphocytes for a reason. They hang out in your lymph system. So most of them are in your lymph nodes or in your tonsils or in your connective tissue. They're hanging out in other places, essentially. Your monocytes are relatively rare. They don't stick around for that long because they differentiate into another kind of cell called a macrophage. Eosinophils in the United States are usually fairly low. Basophils, usually pretty darn low, although if you have allergies, those counts can be a little bit higher. Now, coming back to the granulocytes versus the agranulocytes, the stupid memory trick to help you remember which is which. Granulocytes are filled with granules, so it's neutrophil, eosinophil, basophil. Those are all the granulocytes. They are called that because they have these little cytoplasmic granules that make them stain spotty. Those little cytoplasmic granules is what make them granulocytes. The agranulocytes don't have those. They end in cyte. So lymphocyte and monocyte are your 2 agranulocytes. Now, to discuss those in a little bit of detail, I gave you a little bit of table in the notes. I gave you pictures, I think from the most recent version of the textbook. The pictures that I'm showing you on the PowerPoint are from older versions of the textbook. This kind of goes back to don't just study one picture, study lots of different pictures, because guess what? Neutrophils never look the same. Eosinophils never look the same. And so you want to make sure you study different pictures so you understand what they will look like in any form, not just in this one particular picture. So these are all of your granulocytes. Notice the little specks that you can see. They're fairly faint in this one. This is a neutrophil. They get darker in the eosinophil, and they're really super dark in the basophil. The neutrophils in more detail. Again, most abundant white blood cell. I don't know if you guys get to do a blood smear in lab. I don't think you get to. If you ever want to with me, schedule an appointment. We'll do a blood smear. You guys can look at your own blood. You just got to make an appointment with me to do that on the calendly.com thing that I've shared with you guys before. So let's see. Neutrophils are the palest and one of the smaller white blood cells. They have what I like to call a super jacked up nucleus. It is multiple lobed or multi-lobed for short. And what I mean by that is like there's a lobe and then a constriction, and then a lobe, and then a constriction, and then a lobe, and another constriction, and so on. So yeah, jacked up nucleus. It's still just one nucleus, but there's multiple chunks to the nucleus, I guess, if you want to. Neutrophils are your most abundant phagocyte. Phagocytosis we talked about back in AMP1. Remember, that means cellular eating. So these are your white blood cells that do what that GIF showed earlier. They run around, they look for bacteria. If they find bacteria, they eat bacteria. If you get a bacterial infection, these are the first white blood cells on scene. They clean up the area of whatever bacteria might have gotten into you. Next, eosinophils. I've always kind of thought that their nucleus looks like earmuffs or headphones, whichever one you like. So old school earmuffs, think of the Princess Leia earmuffs, because I know this is Texas, we don't really do those. So you get 2 lobes and then there's a little constriction that connects them. Here we get more of the headphone sort of thing. But there's your big old nucleus. It is intermediate in color between the neutrophil and the basophil, so lighter than basophils, darker than neutrophils. These are, again, fairly rare in the bloodstream for people in the Americas, and by America, I mean United States and Canada. These are more common in people who get parasitic infections, and those aren't, again, super common in people who have sanitization, they have food inspectors, things like that. But in places where people are more hunting for their food and worm infections are more common, or they drink contaminated water, so protist infections are more common, they might have more eosinophils that are floating around. This is just a picture to show you a tapeworm infection. If a person were to have a tapeworm infection, they would have a much higher eosinophil count than a person who did not. So instead of the 2 to 4%, maybe they would be shooting for like 6 to 8% eosinophils. They would actually up their production to try to deal with the tapeworm. It wouldn't work. Tapeworms are fairly hardy, but your body would try to fight the tapeworm to kill it. Tapeworms are just really difficult to kill. One of the advantages of that, though, is eosinophils are also really good at lowering your allergy response. And so essentially, there's this weird little story. There are some places where they market allergy pills, and people would take the allergy pill with the wonderful side effect of you would also lose weight. And it turned out what was in the allergy pills that totally worked. Allergies would essentially vanish once you had been taking the allergy pill for a while. And then you would notice you lost a lot of weight. So it's marvelous. My allergies are gone. I've lost weight, like I'm sexy again. And then it turns out it was because the allergy pills were just tapeworm eggs that you had been ingesting. So essentially you can live with a runny nose, itchy eyes your whole entire life, or tapeworms or hookworms or something. And as a person who suffers from allergies, I honestly don't know which is worse. You be the judge for yourself, I suppose. Okay, basophils. These are the darkest and the rarest of all the granulocytes. Their nucleus, if you can see it, they again are very, very dark, is usually vaguely S-shaped. This one's sort of backwards, but you can see the S shape floating around in there as well. The granules are very, very dark, and they are very, very common, which is why it is difficult to see the nucleus inside of there. These cells are specialized for the release of histamine. So histamine's job is to promote inflammation. So this is the white blood cell that gives you allergic reactions, essentially. The opposite of the eosinophil. Your agranulocytes. There's two that we are going to talk about here. Neither of them have granules within their cytoplasm. First of those is the lymphocyte. Now, there's different kinds of lymphocytes. You can even see different ones in the bloodstream. Hey, Captain, stop it. Dog's trying to eat his bed. Try to give you good things, and what do? You eat your bed. Stop it. The key to a lymphocyte is essentially it's a cell with a giant nucleus. The nucleus takes up nearly the whole entire cell. So, poof, there it is. Same thing in that bottom picture. Again, these cells, while you will find some in your bloodstream, they're mostly hanging out in the lymph system. There are different kinds that we will talk about more. Now he's going to squeak. Oh, you frustrating little thing. Stop playing with loud things. Now I forgot where. Yes, you're very cute, but you're very annoying. Stop it. Stop it. I should pause the video. I'm so lost now. Nucleus, lymphocytes. We will talk about lymphocytes way more when we get to the immune system. T lymphocytes mature in the thymus gland. B lymphocytes mature in the bone marrow. Already said that. And again, we will talk about them in more detail later. Monocytes. These are by far the biggest white blood cell that you have. Notice that it's about the size of 4 of your red blood cells all rolled in together. They tend to have a vaguely bean-shaped or sometimes kind of U-shaped nucleus, way bigger than any of the granulocytes. Plus, again, no granules, so you should be able to figure it out pretty easily. Monocytes are they are a type of stem cell, which means they are not fully matured yet. You release them, and they float around in your bloodstream. And whenever you get an infection that's been hanging on for a while and your neutrophils have been fighting that infection, but they're not really making headway, your monocytes are going to differentiate or mature into macrophages, which if you break that word down, macro is big, Phage is eater, so they are big eaters. They are better at phagocytosis than neutrophils. They can eat more than the neutrophils. So if you have a chronic bacterial infection, macrophages are the cell that's going to help you try to clear that infection. It just takes them longer to get there than neutrophils, so they're sort of the cleanup team. Okay. Next up, antibodies. So antibodies are proteins. They are not cells. Antibodies are secreted by B cells, specifically a type of B cell called a plasma cell that we will talk about more in the immune system. Antibodies, I like to think of them sort of like they're bullets, and the plasma cells are the snipers. So the plasma cells shoot the antibodies, and then the antibodies help kill whatever pathogen is moving around in your body. They are always Y-shaped. They will sometimes clump together to make conglomerates, but even then, the conglomerate is going to be made out of multiple Y-shaped proteins. They have variable regions that are specific to certain pathogens. So like you have antibodies against whatever, the common cold. You have antibodies against the flu. Probably most of you have been vaccinated against chickenpox, so you have antibodies against chickenpox. You have antibodies against polio because probably you've been vaccinated against polio. So you have different antibodies to fight different pathogens that you have either been vaccinated against or that you have been sick with and then gotten better from. Macrophages I described pretty well earlier, so get what you need from the slide after a nice little pause. These are the pictures that I showed you earlier as we were going through this. This is from an older version of the textbook. All of the granulocytes are at the top, A, B, and C. All the agranulocytes are at the bottom, D and E. Hopefully you can see that for yourself because, again, the granules are those specks, and you can see those in the top 3 pictures and then not see them at the bottom pictures. From there, what you guys really need to be able to do is get good at just going, okay, this one's totally a neutrophil, and I can tell because it's got the most jacked up nucleus out of anything that is up here. This one, earmuffs. Earmuffs and eosinophil go together. This one, big ol' S-shaped nucleus, but it's really dark and hard to see, must be a basophil. Lymphocyte, monocyte, the biggest one. Flashcards can really help you out with that. So one of the reasons I gave you the pictures in the notes is so you could make yourself some flashcards by copy-pasting the pictures over to some flashcards should you want to. This table, 17.2 from your textbook, is really good at just kind of summarizing basic appearance, basic function, how long does it take you to make them, although I don't focus on that all that much. How many of them do you have per microliter of blood, which again, I don't focus on all that much, but should you just want to know it. I would focus on more, do I recognize it? And do I know what it does? If you know those things, you should pretty much be okay for me. We've talked about everything on that table up through platelets. We haven't done the platelets yet. Okay. Interleukins are, I mentioned earlier, there's a set of chemicals that help you churn out white blood cells faster to do that leukocytosis thing. Interleukins are one of the classes of chemicals that help us do that. There's a whole bunch of different interleukins. Some of them are good, some of them are bad, some of them cancer messes with, some of them cancer can be treated with. They're complicated, essentially, and we don't have time to talk about a bazillion of them. I also just kind of wanted to show you, this is what bone marrow looks like on a biopsy. So if you were to take a sample and put it on a slide, that's what it looks like. It does not look like blood. It is much, much denser. And then this is interleukin 2 is a specific interleukin that is used to treat some forms of cancer. Okay. The stem cells that are going to give rise to our white blood cells. We still start with the same hemocytoblast that makes all of the red blood cells as well. When the hemocytoblast differentiates this time, though, it becomes one of 2 types of stem cells, either the myeloid stem cell or the lymphoid stem cell, and I circled that poorly. The myeloid stem cell does most of the work in relation to the white blood cell. It's going to make 4 out of the 5 types of white blood cells. The lymphoid stem cell just does lymphocytes, and that's it. Now, because we're getting to this here in just a minute, if one of these 2 stem cells ends up dividing more often than it's supposed to, that can end up giving you leukemia. And so you can have a specific form of leukemia like myelocytic or lymphocytic leukemia, and it tells you which one of these 2 cells has decided to go rogue. And which of these you would end up overproducing. So essentially you would know which stem cell is causing the problems there. Leukopenia is the opposite of leukemia. Leukopenia, again, leuko, white. Penia means deficient in, so you are not making enough white blood cells. If you're on chemotherapy, you would have this as a side effect of that. Maybe your bone marrow is just slowing down with age, so this is something that you might see as you get older. If you have a person who's taking steroids because they have an autoimmune condition or something, they can develop leukopenia as well. Leukemia, exact opposite. They are making way too many white blood cells. The white blood cells that they are making, though, they are broken. So they are going to have the same symptoms that a person with leukopenia would typically have, which is frequent infections that are not clearing up very well. But when you look at the blood, they have a lot of white blood cells, way more than you are supposed to see floating around in blood. But they do not look right. None of those cells are shaped like they are supposed to. These are all lymphocytes that are malformed. So this is the lymphocytic, our lymphoid stem cell is the one that's caused this particular leukemia off over there. Okay. What do chronic and acute mean when in reference to leukemia? So ordinarily, chronic means you have something for a long time. Acute means you have it, you get better. That is not what those terms mean in reference to leukemia. Chronic means you have it for a long time. It still kills you at the end. It just took longer to do it. Acute means you have it for a short period. It rages and burns fast and it kills you very shortly. Leukemia is going to kill you without medical treatment. With medical treatment, we have come a long way in treating leukemia, so it is not the death sentence that it used to be. It does still kill a lot of people, don't get me wrong, but it doesn't kill 100% of people anymore. You tend to see acute leukemia more in kids versus chronic leukemia. You tend to see that more in older individuals. Infectious mononucleosis is caused by the Epstein-Barr virus. Most people just call it mono. Mono is a viral infection that infects B cells. And it makes people churn out too many, again, broken lymphocytes. Honestly, Epstein-Barr and mono, it's one of the most common infections that is out there. If you've been to high school, you probably had it because basically everybody in high school is sharing drinks, sharing cigarettes, sharing vapes, and making out with each other. And so it goes through high schools without any problem, essentially. So the chance of a person making it to adulthood and not having it is actually really slim. And the reason that I want to mention that is because there was actually just a recent article in Science that shows that there is a link between the Epstein-Barr virus and the development of multiple sclerosis. Again, it might not be a direct causal link, but using veterans as our research group, almost all of the people that developed multiple sclerosis had been infected with the Epstein-Barr virus versus people that had not been infected. There was a lower incidence of people who developed multiple sclerosis. And so here's the thing. Not only does this suck when you get mono, imagine the flu times like 10, super fatigued, super good fever, super sore throat that can actually inflame the tonsils so much that it makes it difficult to eat and difficult to breathe. It increases your risk of developing lymphocancers later on in life, which I said that in sort of a weird way, but cancer of the lymph nodes later in life. And now we're also saying increases your risk of developing multiple sclerosis based on some of the more recent evidence. So I don't know, teach your kids to not swap spit as much as we used to as kids is the moral of that story. That's where I'm going to stop this video because I think I've talked too much and shared